Hi, today we're going to learn how to solve problem 1.4a and b in the Griffiths and Schroeder quantum mechanics book. I think it's easier to start off with question 1.4b just to see what this graph looks like. So this graph, the wave function of x and at time 0. So this will be the x-axis. So we could label out the major points on the x-axis first. So from 0 to a, and then from a to b, and then b onwards, or 0 onwards. So we know that from 0 to a is described by this function, and this function is just a linear function with the slope of a, big A, capital A over small, lowercase a. So it's going to look something like this. And it's going to stop at a point capital A, since small a over a is just 1. So slope is equal to big A over small a. And then the next part from A to B, it will have a slope of negative big A over B minus A. And then it's going to end at 0 once it's at B. And then onwards, it's just 0. And then here it's also 0 to the left. The reason why it ends at 0 is because b minus b is 0. Okay. Yep, that's 1.4b. Now 1.4a asks us to normalize big A, and the way to do that is to write the probability function and then normalize it from there. So this will be the square of the wave function, and this must equal 1. Okay, and since these intervals are defined by different functions, we have to split the integral up into this part here and then another part right here. So the first half of this function will look something like from 0 to a, and then a squared x squared over little a squared dx. And then this other half will be from a to b, and this will be a squared and then b minus x squared over b minus a squared dx. Okay, now we could solve this left integral first. This will be a squared x cubed over 3a squared from 0 to a. This will be, we can ignore the 0 case. This will just be 0. It's going to be a squared, a cubed over 3a squared. These will cancel, and then it will be a squared, a over 3. Okay, now we can do the right integral. With this one, we want to do a u substitution for b minus x. So u is equal to b minus x, and then du dx is equal to negative 1. So du is equal to negative dx. And we also want to find the values for the bounds. So the initial will be b minus a, and then the final will be 0, since it's b minus b. Okay, now that we have these values, we just substitute in to the integral. So the initial will be b minus a, the final will be 0, and then it will be a squared u squared, yes, and then there should be a negative in front since this will be du, and then b minus a squared du. Okay, now we take this integral like normal. It will be a squared u cubed over 3 b minus a squared from b minus a to 0. We could ignore the 0 case. It will just turn this whole thing to 0. This negative will disappear since it's we're doing the initial value. So this will be a squared b minus a cubed over 3 b minus a squared. These will cancel. Okay, now we could combine this and this together. Since we split up the integrals, we have to add these two. And once we add these two, a squared a over 3, yep, plus a squared b over 3. We could take the a squared out, and since they have the same denominator, we could put them together. So a plus b minus a over 3. These cancel, and we have to remember that all this must equal 1. So we set this entire thing equal to 1. And then now we're at close to the final solution. It will be a squared b over 3 is equal to 1. And we know that a must equal to the square root of 3 over b. I hope this helps. If there are any other questions, feel free to leave it in the comments. So just a quick summary. What we did is we used this here, which is the probability density, and then we took the integral of it from negative infinity to infinity, and we know that it must equal to 1. And in order for this to be true, we have to make a certain value to normalize the function. Okay, thank you.